Hello, thank you for watching this video. So in this video, we're doing question 3 of November 2021 question paper mathematics paper 1. And this is the analytical geometry. So I'm going to read question 3 statement and then answer the questions that follow. So let's go. In the diagram, A, B, and C are vertices of triangle ABC. Line BC is produced to H and cut the x-axis at E. AB and AC intersects the x-axis at F and G respectively. The angle of inclination of line AB is 81.87. Let me try to read this thing again. They are saying, in the diagram, A, B, and C are vertices of triangle ABC. Line BC is produced to H and cut the x-axis at E. AB and AC intersects the x-axis at F and G respectively. They went on to say the angle of inclination AB or of line AB is 81.87. So basically they've given us a diagram similar to this one, right? So they're telling us that A, B, and C are vertices of this triangle. So they are the corners of this triangle. No problem. They went on to say that the line BC, which is this line here, BC, is produced to H, which means this line BC is extended to H. So it has been extended to that point H over there. And during that extension, it cuts the x-axis at point E, which is this point here. So we have a triangle ABC with corners A, B, and C. No problem. So this side of this triangle BC is extended to H. Is produced to H, and during the process of being produced or being extended, it cuts the x-axis where at E. No problem. They went on to say AB and AC, which is your AB and AC, right? They say they intersects the x-axis at F and G respectively. So we should be having F here and G. So they say this line AB and AC, they intersect these points, it intersects the x-axis at F and G respectively. You can see here is your AB and intersects your x-axis at F, and here is your AC, intersects the x-axis at G over there. That's what they're telling you. No problem. So let's go to the questions now. So we see 3.1. What are they saying? At 3.1, they're saying calculate the gradient of, so 3.1.1, calculate the gradient of BE. So at 3.1.1, right? They want the gradient of what? Of BE. They want the gradient of BE. So what is the coordinates of B? The coordinates of B is what? Actually, you don't have the coordinates. You only have K and K, but you have the coordinates of E to be what? To be 12 and 0, right? So they want you to find the gradient of BE, which is this line over here, right? But you don't have the coordinates of B. You only have the coordinates of E, and the other coordinates that you have on that line are the coordinates of C, right? So if the points lie on the same line, they are called collinear. So collinear points are points that lie on the same line. No problem. So what you know about points that lie on the same line, they have the same gradient, because an equation of a line is in the form y is equal to mx plus c. An equation of a line have this form or have this shape, or an equation of a line looks like this. So where what? Where m is the gradient, right? We know this. Where m is the gradient. So if points are collinear, they lie on the same line, which means that they all have the same equation. Because if the points lie on the same line, which means they share the same equation, which means there's one equation that satisfy all those points, which means if you plug the x coordinate, you'll get the y coordinate. That's what it means. So, what you're learning here, you're learning that you know that you can see actually that B, C, E, and H are collinear, which is they lie on the same line. If they lie on the same line, which is they fall on the same straight line. And if they fall on the same straight line, they have the same gradient. So now, if you want the gradient of BE, but you don't have B, but you have another point that is collinear with B and E, then you can find that gradient. It should be the same as that of B. So, we can say, right, I'll make it a bit long so that at least it makes sense. So you can say your B, C, E, and H are collinear. They are collinear. What does collinear mean? Collinear mean that the points, I'll finish there. The points lie on the same line, which means the points are on the same line. That's what collinear means. So if you look at B, C, E, and H, it's obvious that these points are on the same line. So these points are called collinear. So if the points are collinear, that means they have the same gradient. Because if you're saying they lie on the same line, which is, there's one line which they lie on, which is that have the shape like this. So which means they all lie on this line, on a line similar to this one. So which means the gradient, which is M there, for all points is the same. Or say the gradient between points is the same. So if you take any 2 points and find the gradient between, it should be the same. What that means is, if you find the gradient of B, C, which is B and C, it should be equal to the gradient of what? Of B, BE, because they lie on the same line, which is equal to the gradient of BH, which is equal to the gradient of BH, which is equal to the gradient of CE, which is equal to the gradient of CH, which is the gradient, which, the point is, if you take any 2 points, the gradient between any 2 points should be the same. That's what I'm trying to write there. So the point is, you want the gradient of BE, but if you can find the gradient of what? Of CE, you'll also know what the gradient of BE is, because they're all on the same line. So they should have the same gradient. Because the only coordinates that you have are those of C and E. But you know, because C and E and B are collinear, they lie on the same line. So they should have the same gradient. So what you should do, you should find the gradient of CE. It should be the same as that of BE. Let's do that. So, let's find the gradient of CE. What is the coordinates of C? The coordinates of C is 4 and 2. Right? It's 4 and minus 2. 4 and minus 2. No problem. And the coordinates of E is 12 and 0. So you want the gradient of CE. You know that gradient of CE is the same as that of BE because they are collinear. They lie on the same line. So if they lie on the same line, they should have the same gradient because there's a unique gradient that satisfies a certain line. There's one gradient that will satisfy. So all points that lie on the same line will have the same gradient. So what do? Let's find the gradient. So set M, which is the gradient of CE, is equal to what? Y of C minus Y of E over X of C minus X of E, which is equal to what? Y of C is minus 2 minus Y of E, which is 0, divided. This should be 0, not 6. Divided by what? Divide by x of c. X of c is 4 minus x of e, which is 0, which is 12, sorry. So your answer to this, punch that in your calculator and see what you find. That's what I'm going to do. Say what? You say minus 2 minus 0 over 4 minus 12. You find that your gradient is equal to 1 over 4. So your gradient is equal to 1 over 4. So the gradient of CE is equal to 1 over 4, which is also the same as the gradient of what? Of BE, which you were asked to find. Why? Because you can say your B, C, E are collinear. Which they lie on the same line. So they should have the same gradient. So we're done with 3.1.1. Go to the next one, 3.1.2. So this should be the gradient of CE. 3.1.2 now. Done. We move to the next one. They're saying at 3.1.2, calculate the gradient of AB. So at 3.1.2, they want the gradient of AB. What is AB? AB is this line over here, right? So they want the gradient of this line. Also here, you are missing B as well. But you have the angle of inclination. So you know that the gradient is also equal to the tangent of the angle of inclination. So you know that your gradient M is equal to tangent of your angle of inclination. Your angle of inclination is 81.87. So your gradient will be equal to the tangent of 81.87. Should be 1. So the answer to this will be your gradient of what? The gradient of AB. Gradient of AB. Tangent of your angle of inclination. Let's take the tangent of your angle of inclination and see what we find. The answer is 7. So the answer that we get is 7. So the gradient of AB is equal to 7. Looks like we're done here. So what I can do is I can put this information on the diagram. So and say that the gradient of this line is equal to 1 over 4, right? And the gradient of this line is equal to 7. That's what we have. Then we move to the next question, which is what? Which is 3.2. What are they saying in 3.2? They are saying determine the equation of BE in the form y is equal to mx plus c. So they say find the line BE, the equation of BE in the form y is equal to mx plus c. That's what they wanted to find. They wanted to determine the equation of BE in the form y is equal to mx plus c. No problem. How do we do this? We say, okay, for the line, we need the gradient, right? We need the gradient of BE. What is the gradient? Because this is the gradient of your line of interest, which is BE. What is the gradient of BE? We found that the gradient of BE is equal to 1 over 4. Right? Then, the only thing that will be missing will be this constant over here. So to find this constant over here, you need at least 1 point on the line BE. So where is BE? BE is this line over here. So you have more than 1 point. You have 2 points actually, this one and that one. So what you can do, we can find the value of what? The value of C. So say, okay, which point are we taking? We can take C or you're taking B. It should come out the same because they lie on the same line. So they are defined by the same line. So let's take E. E is equal to 12 and 0. Right? No problem. So what is the equation? So now I want to find that point over there. So Y is equal to M of BE X plus C, which is the same like that. So Y is equal to M of BE is the gradient of BE, which is 1 over 4 X plus 12. Actually not plus 12, plus C. And then now 1C. So we use this point that we know, or we could have used this one as well. It will come out the same, to find this value over here. So what do? We say, okay, this is Y, so we put 0 here, is equal to 1 over 4 into X. What is your X value? It's 12 plus C. So 0 is equal to, what is the answer to this? It's 3 plus C. Therefore, your C is equal to minus 3. So you have everything now. Therefore, your line BC have the equation Y is equal to 1 over 4x minus 3. That is the equation of your line BE. Which line is this line over here? So we can say it is Y is equal to 1 over 4x minus 3. So we know the coordinates at that point is minus 3. So, no problem. So what they've asked us to find is the gradient of BE, the gradient of AB, and the equation of the line BE, which is this one here. So we're done with this question. We're going to go to 3.3. But I suppose I'll need more space, so I'll clean the board and then we'll go to 3.3. So let's go. Okay, so now we're doing 3.3 now. I've cleaned the board, everyone is happy. So let's go to 3.3. 3.3, they're saying calculate, then the 3.3.1. Calculate the coordinates of B, where K is less than 0. So, they want us to calculate the coordinates of B, which is this point here, right? Where K is what? Is less than 0. That's what they want us to find. So, what do we know? We know that B lies on this line AB, right? And it lies on this line BE, which is this one over here. So, you can say your B lie on AB, which is true, because it lies on this line. At the same time, your B lies on BE, which is, it is also on this line. So, since your B lies on this line, for this line, you have the equation for this line to be this one here. So, the line BE is defined by Y is equal to 1 over 4x minus 3. This is the line that defined BE. No problem. So, which means this is our, if we have the coordinates of B to be K and K, right? This is the X coordinate and this is the Y coordinate. This is the X coordinate K and this is the Y coordinate, which is K. Which means we can substitute our Y coordinate here and substitute our X coordinate there and try to find X. How do we do that? We say, okay, Y is equal to 1 over 4x minus 3. But what is Y? Y is K is equal to 1 over 4x, which is what? Which is also K, minus 3. This is what you have. So you have your K is equal to 1 over 4 of x, which is K, minus 3, because your X and Y are K. So substitute your X values there, your X and Y values there. So what do you get? You get that K is equal to, what is that? It's 1 over 4K minus 3. Transpose this to the side. You get that K minus a quarter of K is equal to minus 3. So what you get is 3 over 4K is equal to minus 3. That's what you get. Then you divide by 3 over 4. You divide by 3 over 4. So the easy way of writing this to your calculator, write it as minus 3 divide by 3 over 4. That's an easy way of writing it. So I always advise students to write it that way. Because some students get confused with typing this. So every time when you're dividing something by a fraction, or maybe you're dividing a fraction by something else, try to write it this form. There are few chances that you can go wrong. So 3 over 4 and 3 over 4 go away. So k is equal to, punch this on your calculator, you'll see this one and that one will go away, and then your answer will be minus 4, which means your k is minus 4. And they said that your k should be less than 0. So the coordinates for b was k and k, right? But your k is minus 4, so which means your coordinates for b is minus 4 and minus 4. Done with this one. Then we move to 3.2.2. Okay. So now we're going to do 3.2.2. They're saying calculate the size of A. So they want us to find the size of A, of angle A. That's what they want us to find. Calculate the size of angle A. So they want us to find this size over here. No problem. What do we know? So at this point, this is what? 4 marks. At this point, if you look in triangle A, F, G. Let's look in triangle A, F, G, which is A, F, G. If we look at this as one triangle, right? If we look at this as one triangle, this and this are interior angles of a triangle. So if we can find an exterior angle of a triangle, we'll be able to find the value of that, right? So what we need to find is the exterior angle of this triangle, which is of triangle AFO. No? AFG. AFG. If we find an exterior angle of AFG, we will be fine, right? Because angle G, the exterior angle of this triangle is G, right? Which is this angle there. This angle here is the angle of inclination, right? So we need to find that angle G, which is, how do we name it? We say we need to find A, G, E. We need to find this angle over here. We need to find that angle over there. And that angle G is the angle of inclination. So this angle is the angle of inclination. No problem. So what do you say? You know that to find the angle of inclination, or maybe your gradient, you define is the tangent of the angle of inclination. That's how you define your gradient. So which means your gradient of what? Of AG. Your gradient of AG will give you, will help you to find your angle of inclination, which is AGE, which is what you want to find. So the tangent of this angle will give you the gradient. So if you find the gradient, which is this, you'll be able to find the angle of inclination. So what we need to find, we need to find the gradient of AG, right? So, but look, we don't have the coordinates of G, right? We don't have the coordinates of G. What we have though is the coordinates of what? Of C. And A, G, and C are collinear. They lie on the same line as in the first question, which is 3.1.1. So if they lie on the same line, they have the same gradient. So since we don't have the coordinates of G, what we can find is to find the gradient of AC it will be the same as that of AG because they are all collinear. So what I'm going to say is to say, okay, the gradient of AG is equal to the gradient of AC. Why? This is because A, C, and G are collinear. They are collinear, which is they lie on the same line. So which is the gradient should be the same. So now what we need to find is to find the gradient of AC, which is the same as that of AG. And then we'll be able to find our angle of inclination. No problem. So what do? We say, okay, the gradient of AC, which is A, what is A? The coordinates of A is -2 and 10. The coordinates of C is 4 and -2. Right? So the gradient of AC will be equal to y value of A minus y value of C, all divided by what? X value of A minus X value of C. So the gradient of AC is equal to what? Y value of A is 10 minus y value of C, which is -2, all divided by X value of A, which is what? X value of A, which is -2, minus X value of C, which is 4. So let's find the answer to this. Looks like the answer will be like -2. So 10 minus -2 over -2 minus 4. So your answer is equal to -2. So your gradient of AC is equal to the gradient of AG, and it's equal to -2 because these points are collinear. Same reason that I've given there. So now, what we need to find now, we need to find the angle of inclination AGE. This angle over here, AGE, this angle over here, this one. So, we said that the tangent of your angle of inclination AGE is equal to the gradient of your AG. So, which means the tangent of AGE is equal to what? It is equal to your gradient. What is your gradient? It's -2. And then your AGE, which is the angle of inclination, is equal to arctan -2 plus 180, because this will come out negative. So plus 180. So your AGE is equal to arctan of that of -2 plus 180 degrees. So you get that your angle of inclination is 116.57 degrees. This is your angle of inclination. No problem. What did we need this angle of inclination for? We said this angle of inclination, which I can write here to be what? 116.57 degrees. So this is your angle of inclination. Right? So what you can say is, the reason we found the angle of inclination in the first place, because this angle of inclination is an exterior angle, is an outside angle of triangle AFG. AFG, the exterior angle of AFG is that one there, is G. The exterior angle of triangle AFG is this one over here. And you know, an exterior angle of a triangle is equal to the sum of the interior opposite angles. So this angle of inclination, which is 116, is equal to the sum of the interior opposite angles. So which means your angle there, which is what? I just want to call it G now. G is equal to the sum of the interior opposite angles, which is equal to should be A plus F. What? Why? Because this is an exterior angle of a triangle. This is an exterior angle of a triangle, and an exterior angle of a triangle is equal to the sum of the interior opposite angles. That's what we need to know. No problem. If your exterior angle was out here, this angle is going to be the sum of the opposite angles of the interior opposite angles. No problem. So your G is 116.57 is equal to A, which is what? Which is what we want, plus F. What is F? We're given F to 81.87. So therefore, your A is equal to, transpose this. So you have your 116 minus 81.87. Right? So you get that your A is equal to 34 point. So what did we have? We said 116.57 minus 81.87. So the answer is 34.7. That is the size of angle A. So we're done with this question. We'll go to the next one. And I hope it does make sense to you, as it does to me, at least. Thank you for watching. So let's move. I'll clean the board and then we'll continue. Okay, so now we're doing 3.3.3. They are saying calculate the coordinates of the point of intersections of the diagonals of a parallelogram A, C, E, and S, where S is the point in the first quadrant. Let me read this thing again. Calculate the point of intersection. Calculate the coordinates of the point of intersections of the diagonals of a parallelogram A, C, E, S, where S is the point in the first quadrant. So they say now you have a parallelogram. You have a parallelogram, right? Parallelogram. I hope I wrote it correctly. A, C, E, S. Aces. A, C, E, S. So you think maybe S is somewhere here. I don't know. Let's say S is somewhere there. So if you look at this, this is your CE, right? So which means to have a parallelogram, you need your S maybe just to be somewhere here. It should be somewhere there, so that the parallelogram looks like this maybe. Think of this line as a straight line, not as a curved line. So your parallelogram looks like something like this. This being parallel to that, and that being parallel to that one. And these two are equal and those two are equal. So that's what we have. So now what you know about the parallelogram is that if its diagonals, which are these, right? They bisect, which is they meet at the midpoint. The diagonals of a parallelogram bisect, which is they meet at the midpoint. So if you want the coordinates of what? Of the point of intersection of the diagonals, you want the midpoint of these diagonals. So you have the coordinates of A, you have the coordinates of E, which are those. Then you can find what? You can find the point of intersection, which is the midpoint of the diagonals. Because we know the diagonals of a parallelogram, they bisect, which is they meet at the midpoint. So now the x-coordinate of the point of intersection of those diagonals, right, is equal to x of A plus the x-coordinate of E divided by 2. Because we want to find the midpoint of this diagonal, AE, because we can't find the diagonal of GS because we don't have the coordinates of S. No problem. So what do? And the y-coordinate of the midpoint is equal to y-coordinate of A plus y-coordinate of E, all divided by 2. So the x-coordinate of M, what is it? The x-coordinate of a midpoint is what we're trying to find, right? It's going to be x, which is x-coordinate of A, which is 2, plus x-coordinate of E, which is 12, divided by 2. And the y-coordinate of the midpoint is equal to x-coordinate of A, which is 10, plus y-coordinate of E, which is 0, all divided by 2. So the x-coordinate of the midpoint is what? Is 5. and the y-coordinate of midpoint is 5. So the coordinates of the point of intersection is 5 and 5. Done. We found that. If we're asked to find the coordinates of C, we're going to use the same midpoint formula, but now we'll have the coordinates of the midpoint to find the coordinates of C. Done. So, move to 3.4. I hope this does make sense, but I think it is straightforward. So now we're going to do 3.4. So 3.4 reads as follows. They're saying another point T, where P is greater than 0, is plotted such that the distance ET is equal to the distance BE at 4 root 17. 4 root 17. So they're saying there's another point that is plotted, right? Such that the distance ET, E to that point, and B. So BE is equal to ET. I don't know where ET is, but ET, they're saying, okay, so they're saying there's another point T, right? Where P is like this, and your P is greater than 0. So this thing is in the first quadrant. So they say there's another point that is plotted somewhere in the first quadrant, right? Such that the distance, let's put it maybe here, T, which is P and P. So which is this distance, TE, right? Is equal to what? Is equal to BE, is equal to this distance over here. So this distance and that distance is equal. That's what they're telling you. So we have another point T that is there such that BE, which is this distance over here, and this distance over there is the same. Same with what? It's equal to 4 root 17. Same here as well, which is 4 root 17. So this is the distance BE. That side is TE. It's TE. No problem. What are they saying? They're saying to us, calculate the coordinates of T. They want us to calculate the coordinates of T. They want us to calculate those coordinates. We know the distance. So we know that the distance, TE, is equal to 4 root 17. So this is 3.4.1. They want the coordinates of T. We know the distance TE is equal to that. So the distance, how do you find the distance of TE? If your coordinates T, which is P and P, and you have E, which is 12 and 0, right? No problem. What do? Find the distance. You know the distance formula is equal to x coordinate of T minus x coordinate of E all squared plus y coordinate of T minus y coordinate of E all squared is equal to what? Is equal to 4 root 17. Because we're given that. Let's substitute what these things are. So what do? So okay, the x coordinate of T, what is it? Is P minus x coordinate of E. X coordinate of E is 12 all squared plus y coordinate of T, which is P minus 0 all squared, is equal to 4 root 17. Right? So we square both sides. Because we're trying to find P. So we have to remove this root first because we want this. So we want to get rid of what? Of the square root, like we do in question 1, paper 1. So this and that go away. So here we're left with P minus 12 all squared plus P squared, because this is 0, is equal to the answer to that. Let me punch that on the calculator and see what is the answer of 4 square root of 17 all squared. It's 272. So we have 272 here. Let's expand this. So we have 2 brackets P minus 12 and P minus 12 plus P squared and maybe minus 272. I've transposed this to this side. So if you expand this correctly, it should look similar to P squared minus 24P plus 144 plus P squared, which is this one, minus 272 is equal to 0. So you have 2P squared These are like terms. These have no friend, so minus 24 p. So you say 144 minus 272. 144 minus 272 is equal to 128 is equal to 0. Take this to a quadratic formula, or you factor it. So take out 2 as a common factor. Take it to a quadratic formula if you can factorize. So you have p squared minus 12 p minus 64 is equal to 0. No problem. Then what you're left with is just to factorize this thing over here. So you can say, okay, I have p, right? No problem. Okay, so now we'll factor this. So what do we have? You say, okay, you have p, let me write it down here. So you have 2 into p squared, right? Minus 12p minus 64 is equal to 0. This is what we're trying to factor out. So you have p and p. We're trying to factor what is inside here. P and p. The factors of 64 can have 16 and 4. Right? So this time this gives you p squared, this time this should give you 54. But look at this. This 64 is negative, this thing here. What that tells you is that these signs shouldn't come out the same. Which is, these signs should not be the same. One should be negative and one should be positive. How do you decide? A bigger cross multiplication of these things will take the sign of the middle term. So this time this is 16p, this time this is 4p. So this cross multiplication is bigger. So you should take the sign of the middle term and be negative. And the other should be positive because we said they should not be the same. This time this should be 4p. This and that minus 16p. So if you add these two, get minus 12p, which is what is in the middle. So these are your factors. So which means you have 2 and p minus 16, p plus 4 is equal to 0, right? So if you're multiplying two things and the answer is 0, either p minus 16 is 0, or your p plus 4 is equal to 0. So your p is equal to 16, or your p is equal to minus 4. But we're told that p is greater than 0, so it is positive. So it can't be this one. So this is the correct one. So your coordinates for t should be 16 and 16. We're done with this one. Done. Then we go to the last question, which is, oh, it's not the last question. So we're left with 3.4.2. What are they saying in 3.4.2? They're saying calculate the equation of a circle, right? They're saying calculate the equation of the circle with the center E passing through B and T in the form, okay. So they want us to find the equation of a circle that passes through, that is centered at E, right? So here's E, E is the center of the circle, and passes through what? Through B and T. So it's a circle like this. Let's say it's a circle like this one. Passes through B and T. We know the radius of this circle is the distance, which is 4 root 17, which is the same as that 4 root 17. So the equation of a circle, they want it in the form x minus a all squared plus y minus b all squared. It's called the square of a radius, where a and b are coordinates. Coordinates of what? Of the center. So what we do is say, okay, x minus x coordinate of a circle, center. What is the center? Your center is E, right, which is 12 and 0. So you put your x coordinate of the center to be minus 12 all squared plus y minus b, which is the y coordinate of the center, which is 0, all squared is equal to radius squared. What is the radius? Radius from center to that point, which is we're given 4 root 17, which is the same as that one. So it should be 4 root 17 all squared. So this is the equation of a circle. So this is part A. What is part B? Yeah, just here is the equation of a center of your circle. Just put your A and B, the coordinates of the center, and your radius. Your radius is the distance from the center of the circle to the circumference. So if the circle passes through T and B, this means these distances are coordinates of the circle. These distances are radiuses or radii. Sorry, not radiuses, radii. No problem. Okay, so now we're going to do 3.4.2. What are they saying? They are saying determine the equation of the tangent to the circle at B. So they want us to find the equation of a tangent at B. Where is B? B is this one over here. So a tangent at B would look like this. Look like this thing here. Because this is your circle, right? So this is your tangent at B. Should look like this one. So they want the equation of a tangent at this point here, B, which is the coordinates 4 and minus 4. So what do? We first need the gradient of this tangent. But what we know is that the tangent is perpendicular to the radius of a circle. So this is the radius of our circle. This is the radius of our circle. And we know this gradient is 1 over 4. And this one is perpendicular to 1 over 4. What do we know about the gradients of two perpendicular lines? The product of gradients of two perpendicular lines is minus 1, provided that they are not vertical and horizontal, right? So let's go then and say, okay, the gradient, let me not make it green. The gradient of the radius, right, times the gradient of a tangent is equal to minus 1. Why? Because your radius is perpendicular to your tangent. No problem. What is the gradient of the radius? We calculated it as 1 over 2 times the gradient of a tangent, which is what we are trying to find. It's equal to minus 1. If you solve this, you'll find minus this 1 over 4. You'll get that this is minus 4 if you solve for m of a tangent. M of a tangent. M of a tangent is equal to minus what? Minus 4. Then y is equal to negative 4x plus c. Let's go and find c. You use the coordinates of b. Your b had the coordinates, what? Minus 4 and 4. Because this is the point where the tangent touches b, minus 4 and 4. So you say minus 4 is equal to minus 4 into minus 4 plus c. So minus 4 is equal to minus 16 plus c, which means that your c is equal to 12. Therefore your line will be y is equal to minus 4x plus 12, which doesn't look right. Doesn't look okay. Something is not okay. Something is not right. So b, the coordinates of b is minus 4. Minus 4. This doesn't look okay, because this tangent will be somewhere here. So it should have its y value is negative thing down there. So let me look at it and see what's the problem. Okay, so I see what the problem is. So the problem is this was supposed to be positive, right? So if you transpose this 16 to the side, so you'll have C as minus 20. So your y is equal, your line is equal to this minus 20. So this is the equation of a line. I made a mistake there. So solve the line. Here's the equation of a line. That looks better at least. And I hope it does make sense to you as it does to me. I'm done with this question. Let's move to the next one. Cheers.